Good morning, everybody. I'm Mr. Hartzler, and I want to talk to you about conics, and specifically, we're going to talk about hyperbolas in this video. We're going to go through a couple different examples of finding the equation for hyperbolas based on different pieces of information. So let's start off, and let me share my screen with you. All right, so here's my whiteboard, and let us start off by kind of writing down some formulas related to hyperbolas. We actually have a couple, and they're very similar, but there are a couple of key differences here. You'll notice similarities too between circles and ellipses and hyperbolas here. And this is going to be our first one. Okay, so here's hyperbolas. This one is going to look left and right. So I like to think about these kind of like, let me erase that. I like to think about these like parabolas that have been, there are two of them, they're separate. So ellipses, I almost thought about that as two parabolas coming together. Hyperbolas, I kind of think about those two if they passed through each other. So now they're facing away from each other. So in this case, let me put on a little crosshair here. Okay. And this one is going to open left and right. Something kind of like that. Close to two parabolas that face away from each other. And our vertices are going to be this point here and this point. Those are our vertices. Our center is in the middle. For us, most of the time, it is actually at the origin, so there's not a whole lot of messing around we have to do there. And our foci, or our focuses, are going to be here in the middle. I'll write an F in the middle there. And when they ever talk about a length or a distance, they are always going to be referring to between our vertices here. So this would be the distance in this case. But I also have a different version of this, right? I have the one where y comes first. That's a K. I need to erase that. So with ellipses, it didn't matter which one really came first because they were addition, and we have the commutative property of addition. But here, it is significant which one comes first because we do not have the commutative property of subtraction. You'll notice also the a squared is always going to be first and the b squared is always second. That has a little bit of significance if you happen to look in a textbook or if you do some research online, but I'm going to kind of show you how that is a little bit less important later, at least for us with how I describe this. So in this case, we are actually going to have hyperbolas that go up and down. That's because y came first. So whichever one comes first gives us a lot of information about it, right? So if y is first, we're going to be up and down. Our vertices are here and here. Our focus, or foci, or focuses are inside of our parabola shapes there. Our center is still between the foci or between the vertices, however you want to think about it. We don't have co-vertices on this one. Okay, and I will also point out that we have two slant asymptotes here. We do up here as well. And I will show you kind of an easy-ish way to figure those out as we go through this. Okay, so those are our two main formulas. And let us get started. So let me clear this. Okay, let us start off. This is going to be number 1 on the worksheet associated for one of my students. And that gives us the information that our foci are 6, 0, and -6, 0. Keep in mind, this could be written as plus or minus 6, 0. Okay, so those are the same things. And they told us that the distance there's a distance of 10. So this is helpful. We actually have a good bit of information here. Let us start off by graphing what we do know. So if I've got my graph, I have a focus over here at 1, 2, 3, 4, 5, 6. That is my F. 1, 2, 3, 4, 5, 6. So I have another focus over here at -6. Keep in mind, because my foci are on the x-axis, that means I'm going to have an x squared comes first. I'm going to write down now that I know that. It's going to be x minus h squared. Oh, not plus, it's going to be a minus y minus k squared. And the hk is your center, just like it has been for all the other pieces here. Okay, and then equals 1. That's similar to the ellipse. Okay. I know some pieces of information, right? I know my focus, but I also know the distance. The distance here, being 10, is going to be between my vertices. And if I creep in or count in from my foci, I know that my center is actually at my origin. That's nice. So from my center, my origin here, I'm going to count out 5 in each direction because that'll give me a total of 10. So I am going to do this in red. So I know I have a vertex here and I have a vertex here. Symbolize that with little V's. The next thing I need to know is the a squared part and the b squared part. But some of that information is already given, but we maybe didn't write it down. So the a squared is still going to be coming from my vertices, just like it was for ellipses. And how far away is my vertex from the center? Well, it's over here at -5 and over here at +5. So that distance is 5. That's going to be my a value in this case. Okay, again, coming from my distance of 10, that's going to give me that number. So I also know that my center is at the origin, so my h and k are both zeros. So I'm going to simplify what I have a little bit. I have an x squared over 5 squared. Again, that 5 is coming from our distance, minus y squared. Again, h or k is 0 because I'm at the origin. I don't know what b squared is yet, and equals 1. Now I'm going to have to use the foci again to figure out what my b squared number is. So for ellipses, I had my major squared equals minor squared plus foci squared. So this one's going to be a little bit different. Well, I think I actually maybe misspoke there. Anyway, the hyperbolas are going to be, what we're going to say is c squared equals a squared plus b squared. Okay. Just the same as the Pythagorean theorem, except in this case, over here we have our major, or sorry, not major, we have our foci. That's our distance for our foci. And then a and b, the a squared number comes first, and the b squared comes second. Okay, so that's whatever's in the formula, the first denominator plus the second denominator. So I have c squared comes from the distance from my foci to my center, which is going to be 6. Okay, because from my center out, I go 6. So this is 6 squared equals a squared. We wrote that over here, right? That's 5 squared. And I don't know what b squared is. So now we've got to simplify a little bit further. So I have 36 equals 25 plus b squared. So I subtract the 25 over and I end up with 11 equals b squared. So b equals plus or minus square root of 11. That's a prime number, doesn't simplify any further. Okay, it is what it is, right? But remember, b squared actually goes into my denominator, so I don't even have to square root it. I can just leave it as a b squared. So my final answer is x squared over 25, because that's what 5 squared is, minus y squared over 11 equals 1. I know we went through a lot of things there, but the great thing about this is you can rewind and watch that again, but really no single part of this is too terribly complicated. We used our foci, we graphed them, and that helped determine where our center was. And once we had our center, we kind of plugged that in so that our numerator is pretty simplified because we're at the origin. Then we found a squared because of the distance that they gave us. So that distance is always going to refer to the first denominator. Okay, it was a distance of 10, but that was from vertex to vertex. I really only care about center to each vertex or center to foci, whichever part it is. And that then gave us this 5, and it needs to be squared when it goes into the denominator. Then I used foci squared equals first denominator plus second denominator to find out what my second denominator was. Okay, let's save this, let's clear it, and let's try another. So this one, actually, I'm gonna flip my notes over. This one, we are given some different information. We are given an equation, and they want us to find all of the little pieces. So this is number 3 from the worksheet I gave my students. X squared over 4 minus y squared over 4 equals 1. Okay. First thing I know, I'm adding 0 to both my x's and my y's, right? So that means my center is at the origin. Like I told you, most of them are going to be in this case. I'm just going to do a little c there. The next thing we have to note is x is the first term. So that means I'm going to be a left and right style hyperbola and not an up and down style hyperbola. You can look at that from all the way at the beginning. The next thing that I need to look at is my denominators. They tell me a lot of information, just like they did with the ellipse. The thing underneath the x, if I square root that, that's going to tell me my distance up and down. Okay, so if I square root this 4, that gives me a 2. It's underneath the x, so I'm going to go up 2, and I'm just going to kind of do a little dashed line there. Okay, you'll see why in a second. Then for the y, let's do this in a different color. Oh, actually, I'm going to go down 2 as well. So 1, 2. There's that dotted line. So I did a +2 and a -2 because that's what the square root of 4 is. Same thing over here. Let me change that color up a little bit. Let's use orange. So from this one, I'm going to do square root of 4. Gives me a plus or minus 2 again. So I go left 2 and I go right 2. And I'm going to do some dotted lines. Okay. Now, do you see that little box there? I'm going to highlight it in red because that box is kind of significant here. So I'm going to here. See that? Pretty sweet, right? So that is going to give me a lot of information. It's going to tell me where my vertices are. My vertex, because x comes first, it's going to be a left and right hyperbola. So right here on the edge of this box, that is going to be, those are going to be my vertices. We talked all the way in the beginning that there's asymptotes going on here, right? And those are going to come from these diagonal lines. So diagonally from my box, that's going to then tell me where my asymptotes are. Can't touch asymptotes. So now I know what my graph looks like. Look at that. Isn't that sweet? So cool. Actually makes things kind of simpler, right? It's awesome. So I have my graph, but I'm missing something, right? We typically find our foci or focuses. And I know it's going to be somewhere inside each of these graphs. So it comes from x squared equals a squared plus b squared. And I don't know what c squared is. I know a squared is going to come from my blue stuff, right? That's the first 4. And then I have my second 4 was orange, we'll say, plus 4. So c squared now equals 8. So c equals the square root of 8. Well, that's the same as the square root of 4 times the square root of 2. That simplifies to 2 times square root of 2. Sweet. So that, remember, is going to be inside here somewhere. Here's my C value, my focus. So what is that going to be added to in regard to my center, right? My center is 0, 0. It's here at the origin. We wrote that down initially. What part of that's going to change? Is it going to be my x that changes or my y that changes? Well, it's actually my x that changes, right? I have to shift it left and right. So it's going to be a 0 plus and minus, because I have to go each direction of my center, 2 square root of 2. And then my y doesn't change because I'm on that horizontal axis. So I'm actually just going to leave this, oh, not C anymore, sorry. That was C up here. But now this is foci, and this is foci. See how I turned that? I made it work. It's perfect. 2 square root of 2, it's a plus or minus of that, comma 0. Awesome. I want to point out here one more thing. I'm going to switch to a black pen. The asymptotes here, it depends really if it's a left and right or up and down. So the book will have you switch the a and b depending on which kind of hyperbola you're looking at. So for us in this case, because x came first, this 4 is a squared, and this 4 over here is b squared. I want to tell you it's more important that you put y over x, right? Your rise over run every time. So I am going, so regardless of this, right, it's going to be y equals, I'm going to put y stuff, or y denominator, over x stuff, or the x denominator, and then of course times x. So for us, it's going to be y equals, what's the number underneath y? Okay, it's a 4, but remember we have to square root that, so it's going to be a 2, plus and minus, remember. And then what's the square root of the number underneath x? That's also a 2, and I have to multiply that by x because it's an equation, right? But that simplifies to y equals plus or minus 1 x. And yeah, I know some of you are going to say, do I need to have that 1? No, you don't need to have that 1. I understand if you don't put it there, that's fine. Okay, let's save this and let us move on again. So I have another example that I want to show you. And this one is a different case, right? We've done ones now where I gave you the foci and a distance. We've done one where I just gave you the equation and you had to come up with all the other stuff. Now, this is going to be number 6. Let's say that our vertices are 4, 0, and -4, 0. And we're given an asymptote. And it is y equals plus or minus 3 over 2 equals, or times x. Okay. First thing I'm going to do, like all of these times, right? I don't know if you've noticed this, but I've done it pretty much every time. I draw a graph. I put on those points, 1, 2, 3, 4, vertex, 1, 2, 3, 4, vertex. I'm going to count into the center, and that's going to tell me where my center is, and that ends up being right here. X marks the spot, or a C marks the spot, whatever you want to say. And because my vertices are on that x-axis, I know they have been for all these examples, and I'm sorry about that, but because they're on the x-axis, it's going to start with an x. If they were all up and down or vertically, then I would have a y squared comes first. So I know I'm going to be an x minus h squared over a squared minus y minus k squared over b squared equal 1. I'm going to substitute in that my center is 0, so I have x squared over a squared minus y squared over b squared equal 1. I know a little bit more, right? Because of my vertices, I know what the x number is going to be here. The x number is coming from how far away my vertex is from my center. So it's 1, 2, 3, 4. So I plug a 4 down in there. X squared over 4 squared minus y squared over b squared equal 1. Okay, so that's a 16 as the denominator. Cool. But how do I find b squared? I wasn't given my foci, so I can't use that like c squared equals a squared plus b squared 1. But they gave me my asymptote. I haven't done anything with that yet, so let's use it. They told me that y equals plus or minus 3 over 2 x. Remember, we talked about this, right? The number that's going to be underneath, I'm just going to bring that down first, that fraction. We told you that this is going to be my y stuff over my x stuff, my y denominator over my x denominator, square roots of them, of course. So what's the thing underneath y squared? Well, I don't know what that is. That's a b squared, so I'm going to write b on top. What's the thing that's underneath my x? Okay, 4 squared. I don't want a 16. I want just the 4 part, the square root of my denominator. So it's just going to be a 4. Now I need to solve this for, sorry, got distracted by my own notes. Now I need to solve this for b. So I'm going to cross multiply and divide. So I'm going to multiply this side by 4, multiply this side by 4. What am I left with on the right? I'm actually left with b because these 4s are going to cancel. And then over here, now I have b by itself, right? So I have 4 times 3 is 12, and I still have to divide by the 2. So I have 6 equals b. That tells me this denominator over here. So my final answer for all of this stuff ends up being x squared over 16 minus y squared over 36, right? Because I have to square that 6 once it goes into the denominator, equals 1. Sweet. And if I wanted to find out what my what my foci are, I would have c squared equals a squared plus b squared. So c squared equals 16 plus 36. C squared equals, what's that, 52. I would take the square root of both of those. So c equals square root of 52. Does that simplify? Oh, 4 times, no, 14? No, I don't know. Anyway, we're going to leave it as square root of 52. Not worth taking that long in the video. All right. And then that would be added and subtracted to the x component. So I would end up with, for my foci, plus and minus square root of 52 comma 0. Go team. I think that went well. I think that's it too. I think that's all I wanted to discuss. Awesome. I will finish up this graph though. So y squared over 36. So the square root of that number underneath y tells me how far up and down I go, just like in ellipses. So that was a 6. So I'm going to go up 6. 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4, 5, 6. I'm going to do my little boxy box. I went up a little too high, but you get the idea. So that means I have slant asymptotes here. And sure. All right, so my graph looks like this. Awesome. Remember, you don't cross your asymptotes. Sweet. Go team. And then my focus is somewhere in here and somewhere in here, wherever the square root of 52 is. All right. I hope that was helpful for all of you. If it was, please click that like button. Let me save this and let me end the screen share. There I am. Hopefully this was helpful. If it was, please click that like button down there. If you have questions or comments, or if I made a mistake in this video, which I do sometimes, please don't be such a hater. It happens, right? Teachers make mistakes, whether I'm making a YouTube video or whether I'm up on the whiteboard. Actually making mistakes is what real people do, and I am a real person. So if I made a mistake, just leave that in the comments below, and I might not remake the video because this takes a while to do. But it is good to have that comment there in case somebody else is like, whoa, I think that was an issue. Am I making the mistake, or is he making the mistake? And the comment will help clarify some things. So again, please comment, like, subscribe, show me or tell me what you would like to see more of. And if you have any tips or suggestions for me, I'm always willing to hear and receive those. So part of that helped me to eventually get a better mic, right? I use a Blue Snowball now. And the drawing tablet, that was also some suggestions from students. So please give me some feedback and I can make better videos for you. Subscribe to the channel if you want to see more like this. And I hope all of you have a phenomenal rest of your day. Bye, everybody.